welcome to this Scientific Digest episode on EULAR TV at EULAR 2022. My name is Mrinalini Day. I'm an academic rheumatology trainee based in Liverpool in the UK. Today, I'm delighted to have with me Dr. Steven Zhao, who will be speaking to us about two of his abstracts, which are being presented here at the conference, on Mendelian randomization studies in inflammatory arthritis. Thank you very much for joining us today, Steven.
Pleasure.
So first of all, maybe just tell us a little bit about yourself, and then we can talk a bit about your work.
Yeah, sure. So I am a academic clinical lecturer at the University of Manchester in the UK. And my main research background has been in epidemiology, specifically looking at spondyloarthritis. But a more recent interest of mine has been, exactly as you say, in Mendelian randomization. Yeah, I'd love to tell you more about it.
Yes, so exactly. So if you can just tell our audience, and me actually, what is Mendelian randomization?
So it strikes fear into a lot of people's hearts, as it did me.
Yes.
That's because it's at this odd intersection of different research disciplines. It's not quite genomics, it's not quite epi. And so I suppose it's because it's in the middle, it's different things to different people. So geneticists might consider it a candidate gene study. Someone from epidemiology might think it's instrumental variable analysis, for example. I think the best way to convey what it is to a clinician would be to kind of draw the analogy to a randomized controlled trial. So we've all been told in undergrad training that confounding is a problem, right? Ice cream sales and drowning are not causal, they're just correlated. So how do we get rid of confounding? We can adjust it for it in regression, or we can randomize. So in a trial, you have a population of people who you randomly allocate to a treatment or a control, and if that randomization is sound, you are happy that the confounders are evenly distributed, and what you observe is causal, right? Now, Mendelian randomization, as the name suggests, is similar in that it's almost like a cosmic level trial. It's a quasi-randomized natural experiment. So we were all allocated genes at conception randomly with respect to our environmental confounders. So one of the more famous examples would be alcohol dehydrogenase, for example. So I can't metabolize alcohol. Some of my kinsmen can. That alcohol metabolism gene doesn't really affect anything else apart from alcohol metabolism. It doesn't affect my smoking, doesn't affect my BMI. So if you compare groups of people who have genetically predicted higher levels of alcohol consumption versus lower levels of alcohol consumption, and you follow them over a lifetime, and if the disease outcomes differ, so for instance, if their cardiovascular disease differ or cancer differ, then you're more sure that what you're looking at is causal because of this randomization, rather than just a correlation. Now, obviously, I know we're not talking about alcohol here, but it's often an example used by people who promote Mendelian randomization. So that's what. Is anything not clear about that?
I think that was a really excellent description.
Oh, thank you.
Yes. What I think would be important to me, as you say, as a clinician and a researcher, how can this particular form of methodology be applied for, ultimately in patient care? Maybe giving an example, maybe from some of the work you're presenting.
Sure. So first of all, the reason I asked you is because I often try to explain this, and I'm trying to refine how I explain it to make it more understandable, because it is relatively new. It's not something that we get taught in undergraduate training.
Oh yeah. No.
And instrumental variable methods do not come out of epidemiology, came out of econometrics. Now, you raise a very good point. How is this relevant for clinical practice? And opponents of Mendelian randomization make a valid point in that a lot of it is focused at disease risk, so disease onset. So it has more implications for public health and prevention, rather than you've got rheumatoid arthritis, what's your prognosis going to be? So that is an area to which MR is moving towards, but not quite there yet. So you're right. The vast majority of Mendelian randomizations look at disease risk. Is smoking associated with higher risk of RA? But it doesn't tell us, is smoking associated with poorer prognosis or treatment response to RA, for example. So it has, so far, limited application to the clinical room, to the practice, but I think it offers a lot of mechanistic insight. And I would say the biggest role it plays, of course, with any method, there are assumptions, and there are with MR, statistical assumptions. And I think the biggest role it has is this thing called evidence triangulation. So my background came from pharmacoepidemiology. If you compare one drug against another, you're never sure if you're fully adjusted for channeling bias, right? But if you could apply this different method that has a whole different set of assumptions, and if the two methods give you the same answer, you can be more confident that what you found is the truth, rather than just a confounded. So neither of which should be alone by itself, both together.
So actually, picking up on that, if I put my epidemiology hat on rather than clinician hat, what would you say to convince me then that I need to go into maybe trying Mendelian randomization as a junior researcher, as a methodology? Why can't I just stick to the classical pharmacoepi methods that I'm used to doing?
That's such a good question, Manny. So you will have all seen vitamin this, vitamin that. So vitamin E, D, C, whatever you want to call it, is associated with X, Y, Z. Vitamin D, for example, associated with everything in life, right? And then you carry those observational associations that you were confident you'd adjusted away all the confounders. You carry them forward to a trial, and what happens? Time and time again, those trials are null. And this has happened to selenium, vitamin E, vitamin D, and it's costed who knows how many hundreds of dollars or euros. And the reason I would promote MR is, unlike the traditional observational design, MR called it right for all of these trial outcomes. It was concordant, sometimes confirms, sometimes predicts these trial outcomes. So yes, there are limitations to MR, but put out into the real world, the acid test, in my experience anyway, in the literature, that it's more concordant with subsequent randomized control trials. So that's why you should do it. And the other reason you should do it is just because once you get past the learning curve, it's so easy. Yeah, so the instrumental variable paradigm includes a lot of things we're familiar with. Randomized controlled trial is an instrumental variable method. Yeah. Regression discontinuity, physician preference in pharmacoepi, things that a lot of people see in journals are all the same method. But the minute people see genes, as the minute when I first saw genes out, I was like, oh no.
Scary.
This is scary stuff. Yeah.
And I guess also, you've kind of touched on this, but MR is quicker than a randomized control trial.
Yeah, absolutely.
Yeah.
Yeah.
So, hours rather than years.
Yes. So you raise a very good point. So a lot of MR can be done using data that's already available.
Yeah.
So from previous studies that have done genome-wide association studies on a lot of the diseases that we're familiar with, you can just you can leverage that existing data to answer your questions quite quickly. And it helps to prioritize what you do next, what you carry into trials or what you carry into drug development. So studies have shown that drugs with MR, so this causal design, with this kind of study design, support are more likely to be successful further down the line.
I think what would be really helpful is if you can maybe pick out one of the abstracts that you have presented at EULAR, just so that we can see how it works in practice. Just give us a brief overview.
Sure, absolutely. So I should say in my head there are two types of MR. One is kind of the more mechanistic, looking at protein targets and drug targets, and one's looking at kind of your traditional lifestyle environmental factors. So I didn't submit anything to do with the former, but the latter, the post that I have on Saturday, which please come join me, is on impaired glycemic control and its potential causal association with psoriatic arthritis.
Okay.
So in psoriasis and psoriatic arthritis, we know that these populations have higher risk of diabetes. But we also know that diabetes doesn't happen overnight. You've got impaired glycemic control up to a decade before you develop overt diabetes. So which is the chicken, which is the egg? We don't know. And with traditional observational designs, that's quite hard to answer because we don't measure glycemic control running up to a disease that may or may not happen.
Fine.
So what we did was look at genetically predicted higher levels of HbA1c, glycated hemoglobin, and lower levels of glycated hemoglobin, and we followed up these people over a lifetime to see if their psoriatic arthritis or psoriasis incidence, or whatever, prevalence differs. And it does.
Okay.
Right. So poorer glycemic control increases the risk of psoriatic arthritis. And you think, oh, whatever, that's association. Where's the compelling biology? Yeah. There is compelling biology because the axial form of PSA have excess bone formation that doesn't quite look like axial spondyloarthritis. That looks sometimes a lot more like DISH, hyperostosis. Yeah. And what's DISH associated with? Impaired glycemic control, So we know that this poor metabolic profile does have an effect on what your bones do.
Okay.
So there's compelling biology as well as what the MR showed observationally.
Great. Thank you, Stephen. I think you've convinced me that I need to go and try this out, actually.
Yeah.
A really, really interesting discussion. As Stephen said, do go and check out his posters, which are being presented here at the Congress. Thank you very much for joining us for this Scientific Digest session, and we will see you again soon on EULAR TV. Thank you, Stephen.
Thank you, Minnie.